Hello and welcome to the very first episode of targz. Today we're going to talk about a paper titled The Power of Noise, Redefining Retrieval for RAG Systems. And we have here one of the authors, Fabrizio Silvestri. Welcome, Fabrizio.
Hello, hi, nice to be here.
Well, it's a pleasure to have you here. And before we jump into the paper, do you want to tell us something about your journey?
Okay, yeah, so as I like to say, essentially, I have done everything that could be done by using a PhD. So essentially, I got my PhD from University of Pisa in, let's say, in 2004, and I spent let's say, about, I would say 10 years as a researcher at the National Research Council in Italy and in Pisa in particular. So essentially I've spent all the beginning of my career in Pisa. So I got fed up with Pisa and I left Italy. So I joined Yahoo Labs in Barcelona first and then London, where I've done applied research on advertisement first and then, let's say, retrieval for advertisements or advertisement all around. And then I left Yahoo and I joined Facebook. And I joined Facebook as an engineer, as a software engineer,
okay.
So not as a researcher.
Interesting.
So that's, the third thing that you can do with your PhD. Yeah. You can be an engineer. So I spent a couple of years as an engineer in the search team at Facebook, and then Facebook AI Research Fair opened an office in London as well, and they asked me to join them, and I went back to do research, this time in let's say, more generic things, and I was one of the, let's say, I would say, first users of Hugging Face, because we were using their LLMs even before they released it to the public. And then eventually, for personal reasons, I had to leave London and also Facebook. And then I joined Sapienza as a professor here. So now I've been at Sapienza for almost 5 years.
Cool, yeah. Thank you, Fabrizio, for this introduction. And so let's talk about the paper. So again, the title is Power of Noise, Redefining Retrieval for RAG Systems. So do you want to, let's say, introduce what is the paper about?
Sure. So, RAG, or Retrieval Augmented Generation, is a kind of hot topic. Even though nowadays we all talk about agentic AI, it's essentially a sort of reincarnation generalization of this concept that, by the way, was actually released by Facebook AI Research in London.
Yeah.
And I was actually there when they were working on these. And so actually I've been influenced a lot by that work. And essentially what RAG is about is, instead of just relying on the knowledge stored in an LLM to answer questions, you can use an auxiliary, an external memory from which you retrieve, and then you generate the answer. So Retrieval Augmented Generation stands for that. Now, it's a very interesting piece of technology. It's a very interesting thing. And we were actually interested in understanding what would be, or what was the impact of the content of the context. So what is the context? So as I said, you're using an external memory. You retrieve in the context that you think, that you believe it's necessary to answer the question, right? So now, because you cannot be sure that that's the right context, we wanted to analyze what happened when you start, let's say, playing with the context. So you add things and whatever. So we put ourselves in an ideal situation where you know exactly which content should be in the context, and then we played with the other parts of the context.
Okay.
And that's the idea. And we wanted to observe what would be the outcome of that.
Okay, so and what is the kind of the goal of the paper? What is trying to what is the kind of contribution the paper is giving?
Right. So I can tell you the contribution that eventually the paper gave,
Okay.
and and I can tell you, let's say, the contribution, and I can tell you the path to get to that point,
Sure,
which is
yeah,
interesting in my opinion.
of course.
So the contribution is that essentially we showed that in a context there are different types of contributions, and for the first time we pointed out that the type of results. So in general, let me tell you, let me make a sort of let's say flashback.
Sure.
So in information retrieval, which is the basis, the scientific basis of retrieval augmented generation, you are dealing with a system. It's Google. So you submit a query, you get the results, and then there is a human that looks at the results and decides if there is the answer in these results. So we said, okay, but now we are not producing results for a human. We are producing results for an LLM,
Yeah.
for a language model. So is this different from producing results for a human? And the answer is positive.
Okay.
We discovered that the answer is positive in the sense when you generate an answer or a context, it should be tailored to the LLM that should consume it.
Okay.
And we showed that the context might contain two different types of contributions: positive contributions and negative contributions. Okay? And this is very different from information retrieval, because in information retrieval there was only positive and neutral. So a user is not affected by something that is not relevant. But we discovered that an LLM is instead.
Okay.
You may have results that are reducing the quality of the generated result. All right. And then the surprise, which is then the name of the paper, was that if you add random content, so totally random, that in information retrieval would be considered, of course, neutral.
Yeah.
In our case, we increased the quality of the answer by like even 35%.
Okay.
Which is a lot.
Interesting. Yeah, that's a lot.
And that was the real surprise for us. And then I can even tell you about the path.
Just a couple of questions. So we're talking about
Sure.
open domain question, right? So a question that the user may ask about anything.
Yes,
and
correct.
we'd like to make some kind of example of, question and answer, this kind of how it is kind of working, more or less, just to give an idea, practical idea.
Sure. For instance, you can ask questions like, what's the color of I don't know, the king's horse, okay? Or how many floors are in Buckingham Palace? I mean, these kind of questions. And of course, you can ask more specific questions like, how many jobs has Fabrizio Silvestri changed, right? Now, for this, specifically for this kind of questions, the knowledge in the LLM might not be enough.
Yeah.
And so this is where you rely on the external knowledge, because you pull from your collection a set of results that it's likely to contain the answer, and then you let the LLM figure out the answer from those results.
Okay, and just to get a bit more into detail about the retrieval part, how does it work? So how are documents and content stored to be retrieved?
Yeah, so nowadays there is mainly one way, which is through the use of these vector databases. And vector is the name, is not a random name. They are databases of vectors because you store documents not in their textual form, but you represent them as a series of numbers, vectors, and then these numbers are not random numbers. They are built by other LLMs, for instance. And the idea is that in order to understand which documents are more useful for a given query, you also embed the query, so you represent the query in the same format, so with vectors, and you try to compute the closeness of the query vector versus all the document vectors that you store. There are efficient ways of doing that. And you essentially retrieve the closest vectors. And usually this is done in a few milliseconds. And then there are traditional methods based on indexes, but those are usually rarely used in modern RAG systems.
Okay, so as far as I understand, you get, you basically convert both the, let's say, the document and the query in the same format, and then you take the documents that are, let's say, more, let's say, similar, in between quotes, to the query. Is just what kind of similarities? Is just like, wording, or is more like the meaning itself?
No. It's of course semantic similarity. That's the best part of it. Let's say more traditional methods where, let's say, relying on syntactic similarity. So the number of times they contain the words in a query and stuff like that. So in order to get results that were more oriented towards semantic similarity, you had to apply other techniques like query expansion, terms expansions, and whatever. So in order to make sure that you also capture other possible meanings of the query. So if you say, I don't know, Buckingham Palace, you can actually expand it into Queen's residence or King's residence, and stuff like that. So all these kind of expansions are kind of automatic in the world of let's say embeddings.
Okay, cool. And one last thing before we move to the actual part. You mentioned that made you this kind of discovery about the noise itself. You mentioned positive, negative, and neutral contribution. Can you do an example to clarify what does it mean?
Sure. So so a positive contribution. So imagine you ask the question, how many jobs Fabrizio changed?
Yeah.
Okay. So the positive contribution would be a document containing my bio, and in the bio it's written Fabrizio started at CNR, then Yahoo, then Facebook, and then Sapienza. So the LLM can count that the different number of jobs is 4, and the answer is 4. Then imagine that together with that, you also put in the context a document saying Giovanni Trappolini, a friend of Fabrizio Silvestri, changed 3 jobs in his career.
Okay.
Now, Fabrizio Silvestri is mentioned there, and then the number of jobs is explicit there. So the LLM is taking less of an effort to understand the number of different jobs. And it's quite likely that the answer will actually come from the wrong document saying Fabrizio changed 3 different jobs. So this is a negative contribution. And then imagine you have a document speaking about, I don't know, fishing in the Mediterranean Sea.
Okay, yeah.
In that case, that document is irrelevant.
Okay, cool. So basically it's like, the positive is what is really the actual answer, the document contains the actual answer. The negative is what may confuse the LLM, and the neutral is something that is totally unrelated.
Exactly. This is what we thought.
Okay,
at the beginning.
So this is a good way to start with the path, I guess.
Exactly. This is what we thought at the beginning. We said, okay, positive is that, negative is that. In fact, we call them distracting documents,
okay,
more than negative, because they are distracting the LLM to actually produce the correct answer. Now, the path is the following. We started from another famous paper that is Lost in the Middle, where they show that if you put the exact answer in the middle of the context, this is producing a negative effect in the thing. That is, you are doing, let's say, worse than an LLM without any context, on average, of course.
Yeah, of course.
on average. So we said, okay, this is interesting. It means that not all contributions are created equal, right? So we said, okay, let's try with, instead of taking a single golden document, let's take the retrieved set of documents. Let's put the gold document, let's say, in the best possible position, in the second best, and so on and so forth. And let's enrich the context with documents retrieved from the IR system.
Okay.
And we said, okay, we are expecting the system to perform worse. And in fact, we measured the results, and the results were worse. And that was actually a confirmation. And then I remember I was in this meeting with the other people in the team, and I said, okay, but we need a baseline. And so we need a baseline to compare our results. I say, the simplest one would be to fill in the context with random documents.
Yeah.
And I would expect these to be much worse than to fill, the context with some relevant documents. So we ran the experiments, and Florin, the PhD student that was working at the problem, came up with a table showing the results. I looked at the results and said, okay, Florin, you have to redo all the experiments because, they are clearly bugged, because it's not possible that if you add random documents, you improve the system. There must be an error. So, a couple of weeks passed. The poor guy,
the poor Florin,
the poor Florin, redid all the experiments, checked all the code. We actually checked the code also with the other people, and everything checked out. And then we tried the same with other LLMs. Eventually, this is not shown in the paper. We also tried with, commercial LLMs like OpenAI's ChatGPT and so on and so forth. And the results back then were confirmed. I don't know if this is still the case, because we never tried again. But back then, if you add random documents, you actually improve the results. And when I say random, I mean not just random, like random piece of text, but also, like in our case, we use the random Reddit documents. Now, when I say random, I also mean random collection of tokens, so completely nonsensical.
Okay, yeah.
In that case, it's still good. So there must be something in the way, really relevant random documents affect the way LLMs place the attention on the good ones.
Okay, so it's not a matter of the content of random documents, it's just creating noise, literally.
It's just creating noise. Possibly the dissimilarity with respect to the real positive content.
Oh, yeah, of course.
Possibly.
Yeah, makes sense.
Possibly.
Yeah. And does it matter where you put? So if you put the random, the noise before, after, close to the query, far from the query?
It does.
It does, okay.
It does. Of course it does, in the sense there is this recipe that you should follow when you build RAG systems. You have to put the document that you believe it's the most relevant. In our case, we knew that, but we also did experiments with like a real world system, retrieved the results, and we confirmed the trend. But in our case, we knew what the golden document was, so we placed that close to the query. So you have the question here, and the piece of context right next to it is the golden one, and then we placed random there. And in that case, we observed the maximum amount of gain. By placing the golden document, let's say, far from the query, the gain sometimes goes to zero or even negative. As you saw, lost in the middle effect is still, let's say, playing a role there.
Oh, okay. Yeah. Cool. And does it hold this kind of result for any kind of LLM, or there are some kind of, specific LLMs that for whatever reason, this is not true?
An exception.
Okay.
There is only one exception that we came across, and And it's interesting because I swear to God it wasn't made up.
Okay.
So the exception is the TII Falcon LLM.
Okay.
And the reason why I'm swearing that is to God that is not, let's say, made up is because a couple of authors in the paper are from TII. And we tried with them to kind of debug why, and we don't know. So except for Falcon, we have this confirmed with all the other LLMs, even nowadays.
Oh, okay. That's interesting. Oh, cool.
Yes.
And yeah.
I don't know. We have postulated so Falcon, I don't know if you know, but Falcon from TII is a mainly Arabic LLM.
Ah, okay.
And Arabic, you read from right to left. From right to left.
Yes. Yeah. Okay. Ah.
So maybe, let's say, with English queries, this would actually reduce the effect, right? Because I don't know, but it's really just a crazy idea, and we don't know if this is actually true. Exactly. It's just a speculation. We don't know if this is true or not.
That's interesting. And so, to me, the main question is, did you find out why introducing noise? No? There is some hypothesis?
So it's still an open problem. And when I say why, let me clarify what I mean by saying why. When I say why, I mean a specific, let's say, theorem or something like that clearly states why. We, again, postulated some reasons. In the paper, for instance, we show what happens but it's like an observation. So what happens to the attention to the attention scores in all the cases. And we observed that when you place a distracting document, the attention score is spread between gold and the distracting one. When you don't put it, and also all the other documents gets a little bit of an attention. When you don't put the distracting one, all the other documents get almost zero, and just the golden document is given some attention. But this is more an observation of what's happening, but we do not know why this is happening. We still don't know. It's still an open problem. And I would say it's also a very important one, because this might actually show that maybe the architecture itself is flawed, quote unquote. One thing that we never tried, because they came up later on, is with diffusion language models. Now they are kind of getting attention. And maybe in that case, the power of noise effect would not be present, but we don't know. We never tested it.
Okay, cool. And Fabrizio, one last thing before we end the episode. So, so the paper has been published last year, right?
Yeah.
Has there been any kind of follow-up, or are you still kind of working on that on this kind of let's say topic? Yeah.
So just to remind remind to the people listening to the podcast, the original goal is to understand the role of the retriever in a RAG system versus the role of the LLM, the large language model. So the basic idea is that an LLM is not a human. So maybe the IR system that is used in a RAG system must be adapted to this kind of behavior, to that behavior. So as a follow-up that is very related to, let's say, power of noise, we have started to work on, let's say, re-ranking, for instance, or reordering, rearranging documents in the context in order to optimize all the documents in the context in order to optimize for the end result. We have a paper published at EMNLP on that, which was presented last week.
Okay.
And then now we also have another paper submitted where we said, okay, in the previous paper we optimized for classical IR. metrics like NDCG, for instance. And then we started to question these, like, is NDCG the right metric to optimize? And the answer is clearly no. And now we have a paper submitted where we show we actually produced a new metric, a totally new metric, that if you optimize it, so this is an IR metric for the retrieval system, that if optimized, it gives much better results than optimizing for NDCG, for instance. And this is, so NDCG is not taking into account the distracting documents, whereas our metric is actually taking into account the effect of distracting documents. And so we kind of produce and adapted this metric to the real problem, that is, given to the LLM the right set of results.
Okay, cool. Yeah. Thank you very much. That was super interesting. So yeah, Fabrizio, thank you for being here with us and talking about your research and helping us understanding better your paper. I know that everyone enjoyed it for sure. I did for sure, at least.
Okay, thank you very much. Thank you for having me. It was great, and I really wish good luck to the new podcast.
Thank you very much. So yeah, thank you for listening to us. If you like the content, please hit follow button in Spotify or whatever platform you're using to listen to the podcast. So yeah, thank you very much, and see you at the next episode.